flyaway robot. That's happening today and tomorrow. AI and robotics today and drones tomorrow. Shaban, what is going to happen for the teams if the weather continues this way for the drones? What's the weather mean for the drone pilots and operators?
Well, we have Ihab over here on safety. He's the final word as far as safety is concerned, so that will be his call. There's various kinds of drones on display tomorrow, huge ones, small ones. We've got fixed-wing aircraft, and the weather report looks all right for tomorrow, so it should be okay. And speaking of drones, let's talk about the RTA. If you've been following the news, they've just introduced the passenger carrying drone, which is called the EHang 184. It's, I think, the first passenger carrying drone, or one of the first ones in the world. And for those of you that have flown drones before, maybe you've got a DJI Phantom or a Mavic or an Inspire at home. When you look at the EHang, you will notice instead of having 4 propellers, it's got 8. It's called an X8 basically. So it's 4 propellers on the top and 4 at the bottom. And basically that allows you to have a lot of heavy lift carrying capacity in a very sort of small footprint. That drone is scheduled for operations, I think, in July, as far as I remember the news article.
Excellent. And once again, a warm welcome back to all our audience here today who are joining us from the UAE and around the world as our teams, both in the national and the international category. Again, just a quick view or overview over what it's taken for these teams to get here today. And I mentioned this earlier, it's already an accomplishment to be here as part of the 20 teams presenting in the National and International. They've had 1,017 submissions from over 165 countries this year. And it's our 3rd year. We've both been here for the past 3 years, and I can tell you it's just getting bigger and better as far as the event's concerned, and just as far as the submissions and the technologies that they're also presenting over here. Big thank you to the organizers, ICT Fund and TRA. Also, a huge thank you to the sponsors this year, Dubai Internet City, who have provided us with this lovely venue. The event partner, Samsung, and Digi Robotics, and of course the community partner Makers Builders, who are running the workshops outside, which you could take part of between now and 4:30. Get some hands-on experience on how to build your own robot, and tomorrow they're gonna let you know how you can also get your hands on drones if you like. All right, we've just been told that the next team is going to be back in the next 5 minutes, so we'll be back in 5 minutes to kick off the rest of our AI and robotics teams in the national category. And of course, still coming up today is the international part 1 and part 2 as well. So we'll be back in just 5 minutes.
Ladies and gentlemen, welcome back to the 2017 UAE for Good Awards, and please put your hands together for our host for the day, Marwan Alawadi.
Thank you, Shaban. Welcome back, ladies and gentlemen. Again, we apologize for the long wait. It was just a security precaution to make sure everybody is safe and sound. But we are back with another 2 teams left to go in the national category. Remember, these guys are battling it out for a chance to win 1 million dirhams in the national category. And once we're done with these 2 teams, we still have the international category to go as well. And I don't want to keep you guys waiting anymore, so let's introduce our next team onto the stage to set up. Please welcome to the stage Fun Robotics. All right, we're going to give them 2 minutes as well to set up. And also, I just want to remind everyone that if you're on the social media, the hashtag to use is hashtag UAEA4G. And also, we have the People's Choice Awards as well that you can go onto the website and log on and vote for your favorite teams as well. All right, so get those cameras ready and also get those smiles ready. We might be pointing the camera your way real soon. And in the meantime, Shaban's going to give us some details about our next team, Fun Robotics. They have 2 minutes to set up. Shaban, tell us, what are we going to expect from this next team over here?
Well, Fun Robotics, it's 2 15-year-old individuals, students from Delhi Public School and Dubai International Academy, and they've come up with a project they call Trashberry. They're guided by their mentor, Mohammed, from Fun Robotics. Fun Robotics is actually a robotics club based out of Dubai. And they've built this little smart machine with a Raspberry Pi that allows you to recycle, but in a very special way. It awards you points. So I was talking to them, and they've got an RFID reader built into the system. It can actually read your NOL card, so maybe a project like this in the future, if you put in, let's say, a can of Pepsi that you found on the ground, it may just reward you with something back. And it encourages people to recycle. And what I really, really like about this project, and it's quite similar to one of the other teams we'd seen a little earlier, is they've recycled electronic products. So they've got a Raspberry Pi running in there. They've got components that they've bought off souk.com and a website over here called Zero Ohm. And they're using parts from a printer, Lego Mindstorm kits. And this is quite complicated. When you're using different platforms, you have to write a lot of code. And talking to Fadil and Michael, the 2 young bright minds you see in front of you, they've written a lot of this custom code themselves, which is quite an accomplishment.
Excellent. Thank you very much, Shaban. Once again, our expert over here over the next 2 days, giving us all the tech specs and all the information you need about the teams who are presenting. He has spent the last couple of days spending time with the team and getting all the facts for us, and we'll be talking more about that soon. And I think we're just about ready for the next team. 15 minutes for them. Please put your hands together for Fun Robotics.
Thank you. السلام عليكم. أنا محمد أبو زياد من شركة فن روبوتكس. نفخر اليوم بتقديم نخبة من طلابنا فاضل ومايكل أصحاب فكرة تراشبري. تراشبري هي أول فكرة من نوعها في تخفيض كمية المهملات حول العالم بنسبة ملحوظة تماشياً مع رؤية الإمارات لعام 2030. Good afternoon, everyone. My name is Engineer Mohammed Abu Zayyad from Fun Robotics. I have here my students Fadil and Michael, and they are here to present their best machine, Trashberry, which is going to reduce the amount of recycled materials and help recycling, going with the vision of UAE 2030. I'll leave the stage to my students. Go ahead.
Thank you, sir. This is Trashberry, our innovation designed to end waste.
A project that would bring us ever so closer to zero waste becoming a reality.
And that is exactly what we tried to do. Hi, everyone. I'm Michael, and I like telling stories, but we probably don't have enough time for that now. So, Fadil.
Hi, I'm Fadil, and I like to get on with things. So let's get on with things.
We're here to talk about the project today that we set about with a mission.
Our mission is to provide a definite solution to end waste. We set out to complete this goal by implementing a new and improved waste management system through our innovation. But to find a solution, we had to clearly define the extent of the problem.
Over 7 billion people live on planet Earth today, generating almost 2 billion tons of waste every year.
Less than 19% of this is recycled. And by the year 2100, over 11 million tons of waste will be generated every day.
Even if we don't completely understand these statistics, we need to understand the problem. To put it simply, we are running out of space.
To fix that, we began working on a system that would revolutionize the waste industry and one that would eradicate the very generation of mishandled waste. So we looked at existing systems that were already in place to see what they couldn't fix.
Our main case study was that of the one in Taipei, Taiwan. Now, Taiwan has one of the best recycling rates in the world, but even Taiwan has its flaws. The recycling system in Taipei, Taiwan has an unreliable sorting mechanism and is time and energy consuming. So we tried to look at it to see what it couldn't fix.
We needed a way to improve upon this, to reach an almost 100% recycling rate. So what could the solution to all of this possibly be?
From our case studies, we realized that Project Trashberry needed three things to succeed: convenience, motivation, reliability. Let me explain. Trashberry had to be convenient, meaning it had to be easy for consumers to use. Second, it had to provide motivation. It had to provide incentives for the customer to want to use it. And third, it had to be reliable. It had to provide a fail-safe method to guarantee UAE's 2030 zero waste goal, which is one of the benchmarks we set as an indicator of success.
This got us thinking. How could we incentivize recycling? And how would we tell which consumers were being environmentally aware? Haven't you wished for a way to keep track of everything you've owned? A way to manage all that clutter? Well, this is a similar concept.
Our idea was to ensure that nothing that people used ended up at landfills. So what kind of technology would we use to achieve this goal? Our project uses the popular microcontroller, the Raspberry Pi, in conjunction or integration with RFID tags, which is short for radio frequency identification tags. By thinking a little differently, we realized how we could use the same tags used in the clothing industry to track items sold.
These RFID tags contain valuable information about the products, such as what kind of material it is, so that we can make the waste sorting process infinitely faster.
But we also needed to have rewards for frequent recyclers. So we needed a way to identify to which user each item belonged to.
That is why we came up with the idea of issuing RFID cards to all consumers and have them tag their cards at checkout to identify themselves.
Yep. So when a user recycles, special points are added to his account.
We call these points trashberries, and they work like a credit system in order to give rewards to the users.
So far, it sounds great. It sounded great, in theory. But how could we coerce the population of an entire country to purchase their own unique RFID cards? Again, reality got in the way, but once again, an individual idea solved it. We could simply use an RFID system that was already in place.
We used the NOL card system. A NOL card is something used for travelers to travel on the metro. I'm assuming most of you will have NOL cards? Or at least an Emirates ID, because all residents have to have an Emirates ID.
Using the SDK provided by the government regarding the Emirates ID, we could use this card in integration with our system. There are plenty of RFID systems to choose from in the United Arab Emirates. So how would all of this fit together? How could we make our system work, keeping convenience, motivation, and reliability in mind?
The machine is split into three parts. In a physical form, there's the vending machine and the recycling machine. But then there is also a third component, which puts it all together, the web server.
The two physical parts of our machine, the vending machine and the recycling machine, were both designed to play separate roles in the interaction with the customer. The vending machine being where the customer purchased the products, and the recycling machine being where the customer disposed of their products.
Pictured is the last prototype of our vending and sorting unit, made from old printer and scanner parts. The vending machine is designed to demonstrate how an autonomous system would work, solely through RFID tag use.
After tagging your personalized card, you select what you want to buy, pick it up, and leave. Simple, right? To show you exactly how this works, we will demonstrate with our upgraded vending machine.
As you can see, the vending and recycling machine are in one unit. This is for ease of access and convenience for the user. Now, Michael will demonstrate how to use it.
Can we have the cameras, please?
Yeah.
Great.
First, Michael picks the option to use the vending machine. Now the interface asks the user to tag his card. And so he tags his card. And now it prompts him to enter his PIN code. His PIN code here is 1234, no one peek.
Very secure.
Then he chooses which item he wants to buy.
In this case, I chose Coca-Cola because I'm not a very healthy person. But in general, this machine is used to demonstrate how our system, Trashberry, can be used in any industry, and more specifically, in this case, the beverage industry. So I had the option between orange juice, milk, and Coca-Cola, and I chose Coca-Cola, which means it is an aluminum can. Here, I have the option to pay using credit or Trashberries. Father, would you care to explain?
So he can either use credit, which is already with him, or he can use Trashberries, which are accumulated over a period of time by recycling repeatedly. But Michael hasn't recycled a lot, so he has to go with credit.
You have to recycle more, Michael.
Yeah. Here's where the vending machine works its magic. While I picked what item I want, the vending machine is now dispensing one can of Coca-Cola. Inside our machine, we have used various, could we get a zoom in? Yeah. Inside our machine, we've used various mechanisms. Like, we have straight up recycling by the recycled. We have the head of a scanner, we have a printer, everything directly used, hacked for our own purposes. This was to ensure that we practice what we preach. And now I think it's done. It's disposed my Coca-Cola. Yeah. There you go. So this is the part where I consume my Coca-Cola, or I would if this wasn't made of cardboard. So now I'm going to go ahead and let Father demonstrate how the sorting machine works. Yeah. Okay, so now Fadil picks the option this time to use the sorting machine, and it first asks him to tag his card if he is a registered user. Keep in mind that this is optional, as you don't have to be a registered user to recycle. Now, Fadil is asked to enter his PIN code once again. This two-step verification is very useful, especially if you want to keep track of your points. He's asked to place the item into the machine. And now it detects that it is Coca-Cola. So Fadil is going to go ahead and recycle it. And it drops it into the correct bin. The bottom part, the sorting machine, makes use of EV3 technology, Lego Mindstorms, in communication with the Raspberry Pi. Fadil, you want to go ahead and explain how the app works. Now you've seen how the prototype of the sorting machine works. So you might be wondering what kind of programming, the complexity of the programming behind all of this. I would explain this to you, but my idea of hardcore programming is printing hello world. So I'm going to go ahead and let Fadil go do that for you.
So the programming makes use of several different programming languages, such as Python, Robot-C, SQL, PHP, and a host of others. And all of these are used together to bring together a cohesive user experience. It's very complicated.
Yay, coding. Now all that's fine and dandy, it's amazing. But when it comes down to the brass tacks, what does one prototype of vending/sorting machine do, albeit a handsome one, do for the waste management system as a whole?
But it isn't actually just one prototype or one unit. It's meant to work as a host of units, a whole host of them, working together to create an interconnected web of units.
And when you have all these units around you, all of these units giving you materials, rewarding you when you recycle, you literally have no excuse to litter, which is exactly what we hoped for.
Displayed are the markers of progress. From the very inception of the idea, from the start, we knew that we needed a plausible solution for waste management. The first 5 months or so consisted solely of research.
Tedious, we know, but it's necessary for good ideas. The following 6 months consisted solely of prototyping. Again, tedious, but necessary for great ideas.
October last year was the first time we ever displayed our machine to the public. We needed to see how it was received and how we would have to improve upon it.
And that resulted in our designing and fabricating an upgraded model, that which you see before you. In the coming year, we have quite a lot planned, building up to the release of Trashberry 2.0, exactly a year after the release of our first model.
So if we were to be able to put our plan into action, we needed to know exactly how the revenue and the resources put into circulation would move around.
How Trashberry Incorporated would affect the market or the economy. We needed to know if our system was practical. Long story short, it is.
The cheap cost of RFID tags and the fact that they can be used again and again makes attaching RFID tags to every single store a pretty viable solution. And the long-term effects of Trashberry Inc. make more materials to return to the manufacturer because of the highly efficient sorting mechanism using RFIDs. This leads to enormous profits on an environmental as well as business perspective.
Especially a business perspective. Using Trashberry, the government and private entities as well would be able to keep track of how their products were disposed of. The statistics made available by our system have the capacity to make an incredible impact on the generation of waste.
But now, one question remains. Why Trashberry? Why now? Why Dubai in UAE?
Why Dubai, for that matter? Why UAE? Dubai's encouragement, UAE's encouragement of innovation influenced us, helped us create Trashberry. We believe that by using this system, using Trashberry, we can improve and meet the waste generation goals of this city.
Our project currently focuses on the beverage industry, and so we can use it to change Dubai's recycling rates of aluminum cans alone, which is much lower than the 67% world average. It would have an immensely positive impact on the city.
This wasn't simply a project created by two teenagers using old broken printers and expired Metro card tickets. This wasn't something we built to win a competition.
Trashberry Inc. was designed with a vision to deliver a holistic solution and waste management system to a proactive community. Our demonstration with the soda can was the first step to delivering something that would end waste.
It was the first step to a sustainable Dubai. And that, ladies and gentlemen, is Trashberry Incorporated.
Thank you.
All right, another great presentation there from Fun Robotics on how to do some recycling is what they're doing over there, right? All right. We have one more team left to go in the national category, and that's going to wrap up the first half of the day, and we move on to international. Coming up is a prayer break, and once we return from the prayer break, we'll be in with our last team in the national category who's coming up, and that is NSVIOD. If you pay attention to the screen right now, we're taking a look at what Trashberry put together for us on the screens. It really is like a vending machine, right, Shaban?
Yes, it's a vending machine, and also they've got a sorting machine. So it's a bit of both. I guess the system can be adapted, and like I said, you should see the ingenuity here, where we spend a lot of resources in keeping a city clean, right? And if you can encourage the city's population with incentives, with rewards, to actually do the right thing, and you encourage civic duty, and you also have cleaner streets, it's a win-win situation.
That's right. Also, a little correction over there. We actually have two more teams left to go. I skipped Smart Arm. So Smart Arm's coming up, and then also NSVIOD. That's coming up after the prayer break. And don't forget that there's the workshop going on outside if you want to take a look at that. A little prayer break that will be taking place right now. And if you are on your smartphones, you can head over to the website, a4g.ae. You can vote for your favorite team, whatever you've seen that you like, or even if you're supporting your friends or families or colleagues or friends from school or university, you can go and vote for them because they do get extra points by voting for them on that website. Once again, it's a4g.ae. Just head over to the website, give them a little vote. And we'll be back with our 2 teams remaining in the national category. And then we kick off with our international category today as well. And just so you know, if you're planning on making your way back tomorrow, the doors open at 8 a.m. with our show beginning at 9 a.m. We kick off with the international part 1 and part 2, then the national part 1 and part 2 of the Drones for Good Awards. That is happening tomorrow, so make sure you come back tomorrow and bring your friends, and do come nice and early as well. We're expecting better weather tomorrow over here. So once again, ladies and gentlemen, a short prayer break, and we'll be right back with those 2 national teams. Thanks for being with us here at the UAE for Good Awards.
Dubai's biggest events are now accessible on your smartphone device. Download the Event Security Committee or the ESC app for iOS or Android and get insider access to the latest events at your fingertips. Browse through chronologically or search using the key name, the calendar, or the map, and get insider access to exclusive information, including locations of services inside an event. Once at the event, you can even save your parking location directly through the app. Never miss your favorite events. Save events to your phone's calendar. Browse exclusive content in the media gallery. Download the Event Security Committee app for free on iOS and Android devices in both English and Arabic.
Ladies and gentlemen, welcome back. We are ready to get the show started. 2 more teams left to go in the national category. We're going to tell you about our next team that's coming up on stage in detail, but let's go ahead and welcome them to the stage so they can have their 2 minutes set up. Our next team is Smart Arm. So Smart Arm, if you can make your way to the stage, you have 2 minutes to set up. And again, ladies and gentlemen, welcome back. I know it's been a little bit of a delay today, but the weather has definitely gotten better. We still have the international teams coming up, and I can tell you if you're excited about the national, it just gets more and more exciting in the international category. With all the submissions that we've had and where we are today, you're guaranteed a great show. So Shaban, let's talk about this next team who is setting up. They're going to have their 2 minutes to set up, but what can you tell us about this team? They're called Smart Arm.
So Smart Arm have built one of Dubai's first 3D printed bionic arms. We did have a team a little earlier, but they had composite materials. What the team over here have done is a lot of their project is actually completely 3D printed, and there's very, very good reason for that. They're able to customize the arm for absolutely any kind of patient, because it's a medical device. So it could be a young person, or it could be somebody old, and obviously every human body type is different. And that's the main reasoning behind using the 3D printing technologies. You can basically map someone. So let's say there's an amputee, you can map their arm, and that allows you to build a prosthetic that is custom for that particular person. And they can even change the motors, swap out the electronics. For children, if you want to lift heavy objects, they can put bigger motors in there. And they're controlling this wirelessly. They're the second team, national team we've seen today that are using the EEG technology. So they've got an emotive EEG headset, which allows a person to wirelessly control this arm. And there's also a very, very good reason they're doing that. Normally, prosthetic arms and biomechanical devices require a lot of training, so you'd have to have maybe sometimes surgery done to get it working. In this case, it's completely non-invasive, so you just put on the wireless headset and off you go.
Excellent. Now, the audience has been great today. I see a lot of familiar faces who were here in the morning. I think we want to get some of them maybe on our fan cam, so we're going to point the camera in your direction. You might want to get your phones ready, because as soon as we put you on the screen, you might want to take a picture of yourself and send it back home. We're going to do that for you right after the next team, all right? So get those smiles ready, get your phones ready. Don't forget the hashtag today is UAE4G, in case you're on that social media. Next team, ready to go. Please put your hands together for one of our 2 remaining teams. This is Smart Arm. You have 15 minutes.
Smart Arm. It all started as a graduation project in Ajman University, but we wanted to take this idea to the world for the people that could benefit from it. We are simply 3 graduates from the Biomedical Engineering College, but we have a vision of changing the world. Who we are? Allow me to introduce ourselves. My name is Muhammad Ajam, Walid bin Nasi, and Ubaid al-Najjar. Let us take you on a ride on why we kept working on this idea, or in other words, the problem that inspired us to continue our journey, and what solution did we found to solve this problem, and of course, the live demonstration of our project. So, what problems causes amputation?
3.3 million of people in the world does not have the hand. It's a big number. It only looks, by looking, even if you look at, it's a really big number. So imagine, in the world, 3.3 million of people without hands, surviving somehow, not leading a normal day life. Let's get back to UAE. What happens in UAE? UAE has the highest rate of diabetes. In statistics, UAE rates #1 for diabetes. That's because maybe the lifestyle over here or something else. And secondly, the cancer. It's the 3rd leading cause of death. In even cancer, you need amputation. In diabetes, you need amputation. So we are looking at higher risk of people getting amputated in UAE. Secondly, According to the United Nations, 196 countries, only 10 are not fighting any war. So, even if we look at these statistics, we have a lot of soldiers who are getting injured, who are sacrificing their life for us. So we have to even deal with them. And secondly, the accidents, injuries. Nowadays, it's a very common thing. Accidents during car, motoristic accidents, sometimes also require amputation. So, it's better to give them a better solution. As you can see in the graph, the red line is the UAE. It's really high in the diabetes. Now, every solution exists. Every problem has a solution because people are working on them. But in this era of technology, you don't want something which is simple. You want something that is state of the art. One of the solution, that is EMG, electromyography. This solution uses muscles to control your arm, bionic arm. But what happens is, some of the people who are born without hands, who have deformities, does not even have muscle signals. So, it's like you're leaving them out. But no, we have the better solution for them. Second solution also comes as invasive. So over here we're looking at the elite class, because invasiveness requires a lot of money, a surgery, rehabilitation courses, and also sometimes it will not have infections. That is also not a good solution. Pressure arm is a very simple solution. You apply pressure, your hand is going to contract. You release pressure, your hand is going to relax. So that means this is a simple solution. But in this technology era of technology, you don't want a simple solution.
So why we are doing this whole thing? Beside that, really want to win the 1 million dirhams. But we have some reasons to continue that. The first thing, we have talked to some amputees, and we have found that most of them have lost their confidence. And that's what we are trying to do here. Not only to bring back their arms, but also to bring back their confidence and their self-esteem. And to do that, we have to give them an arm that looks exactly and also functions exactly as the natural arm. Another reason why amputees have lost their confidence is because they need a help in doing a normal daily work. And that's what we are trying to fix here, is to make them independent and get rid of that help of anybody. Also, not only doing daily work, but we want them to be part of building the society. After talking to them, I found that a lot of them have great ideas, creative ideas, but not because they have lost an arm, we'll just keep them away of the society. And of course, we are giving this to the soldiers that might have lost their arms, sacrificing their lives. So, what's our solution? Our solution is an EEG-controlled, 3D printed bionic arm. I know that's confusing, but here's the explanation.
So what is an EEG? EEG is electroencephalography. Brain is a very, very complex organ, sending signals at 431 miles per second. That's even really faster than the car. So imagine sending signals at such a higher rate, and you need to capture those signals, and you have to know which signal is coming from which part of the brain. So EEG does that. As you can see, I'm wearing one. That's a simple, comfortable EEG. Second part of our project is the motors. These motors can lift up to 14 kgs. Now, each finger lifting of 14 kgs, around 5 fingers you have, you can lift 60 kgs easily. So this bionic arm is also strong. 3D printing is a new technology, is a state-of-the-art technology that is also going much better. Now, we have shown you how it works. EEG, the signals are acquired from the brain. They are being transformed into the computer, signalized which signal is for what, and then sent to a processor called Arduino. This Arduino also has connected motors, which will sense which signal is it receiving and which finger it has to move. Over here, fingers are the motors also. We started also with EMG. The one you see in the picture is EMG, which is working. But as I mentioned before, EMG is not a solution for all, whereas EEG is a solution. Now, I've told you how it works. Let's take you to how the 3D printing works.
Regarding to the 3D printing, we select the most advanced technology to manufacture our hand. It's made from the material called PLA, which short of polyitic acids. It's a biocompatible material. It composed around 73 pieces, separated pieces, printed separately. It took around 144 hours to print all these 73 pieces. For assembly, it took 2 days to assemble those 73 pieces and together, then put the motors, tension them together. At the end, the final touches for the cosmetic overview, we put filler coat, then we put paint, then we put primer coat. And the 3D printing gives us an option that we can print any shape, any size, depends on the patient requirements. And now we're gonna show you the live demonstration for the hand, how it's work.
Okay, ladies and gentlemen, I've been waiting all this time, and here it is. We are going to show you our live demonstration. We have planned that we can bring an amputee here with us to help us do the live demo, but unfortunately he's not here for some personal reasons, so I'm sorry for that. But as you can see, Walid was wearing the headset the whole time, so we will do that on him.
So this is a 3D printing. Hello? Yeah. So this is the hand. You can see it's easily 3D printed. The fingers have full mobility, full rotational, and I'm going to control it with my brain, sending commands to it. We're going to do a different signs.
He can control the fingers by his thoughts. And also he can do different moves. This is a contraction, a full contraction and relaxation. And that depends on what he thinks, and that will appear on the hand.
So you have seen that I can control simple movements. And these movements we stored because these are the most common movements. You're holding something, you're contracting your whole hand, or a minute thing you're holding, you can control like this, or something from here. So these are the most used hand commands. We can add more. That's not a problem. That's easily added more. You can add the whole finger, single movement. You can move the single finger, then second finger, then third finger. That's very easy to be moved.
So let's see what's our project advantages. First of all, what makes our project special, or let's say a product that amputees will buy? We put the economic constraints in our priorities because not all the classes can afford the high-cost bionic arm. Biocompatible, as we mentioned in the 3D printing, it's made of a material that is biocompatible and it will not make any infection or harm to the human body in any way, even the headset or the bionic arm. State of art, we printed in the 3D printer, or we manufacture it in the 3D printer, so we can adjust it any shape, any size, depend on the patient need. Non-invasive, it not requires any surgery or any implantation inside the human body. So we are getting out of the harming the human body or the infection. Customizable, as we said, we can customize any shape, any size, depends on the size of the patient, and easy wearable for the amputees. The amputees can wear the headset and the hand independently. Next. So our future plan to add, for this project, to add temperature sensor and pressure sensor. We all know that any amputees, they don't have any sensation for the bionic arm. So we are trying to give them a simple sensation. For example, for the temperature sensor, we are planning to put one sensor in the middle of the hand that indicates the hot and cold objects with two LEDs to know that, to let the amputees know that he is holding a hot or cold objects to not harm the hand or harm himself. Wrist movement is one of our future plans. It is now have a wrist movement, but we are planning to put a full rotational wrist movement would be better than the human arm. Wireless connection, now it is wired connection, but with only the laptop. We are planning to put software on the mobile, so there is no any wires between the head and the arm. Rechargeable battery, is it a rechargeable battery now? But we are looking for one small, strong battery to let it use it for a long time. Yeah, around 25 hours. And we are doing our best to give it a natural look. For example, if the amputee was a kid, so they prefer his hand to be like some favorite heroes. For example, Iron Man or Spider-Man or any heroes. So we can do the shape that the kid wants.
Okay, ladies and gentlemen, who we are? We are Smart Arm, and we are directing thoughts into movements. It's the end of our presentation, but of course it's not the end of our journey. And thank you.
All right, ladies and gentlemen, that was Strong Arm with a great presentation. A round of applause for them once again, please. Thank you. All right, we have one more team left to go. We're just waiting a few moments for them to clear the stage, and we'll introduce the next team to join us here. And that'll be the last team in our national category. We have the recap video going on the screen right now, and well, what a great technology. If you didn't realize what was going on, he was controlling the hand movement with the device that he had on his head. It's great to see some great innovations coming from our national teams, and of course our international teams that are going to be competing in the next round for the $1 million prize that's coming up in just a few moments after we finish with our last team. Shaban's actually over here. Shaban, what can you tell us about the team that just presented Strong Arm? Actually, let me interrupt you right there, Shaban. Let me invite our next team to set up, NSVIOD. We're going to ask you to join us on stage, and you have 2 minutes to get your presentation together. And while you're getting the presentation ready, Shaban can give us some information about Strong Arm.
Smart Arm.
What was that?
The
Smart Arm, sorry.
Smart Arm.
It was a Strong Arm, but they're called Smart Arm.
It actually could be a strong arm, depending, like I said, on the kind of technology. And again, reinforcing the concept of 3D printing being used, Marwan. While the other team is setting up, let's move on and talk a little bit about the next team we have, which is NSVI, which stands for the Navigation System for the Visually Impaired. Essentially, this is a smart walking stick. And when I spoke with the team members, it was very interesting why they've used the walking concept. Most people that are visually impaired already have a walking stick, so modifying it to be a smarter device is actually a very logical thing to do, and as far as I know, it hasn't been done yet.
Great, thanks, Shaban. Also, are you guys ready to get some screen action time? Can we get some of the cameras on some of the people in the audience? So get your camera ready, because you don't know if it's going to be your face on the screen, so you can take a picture of it. We're just waiting for the cameras to give us some fan cam action. Let's see who's going to be on the screen today. We've already got a couple of guys who got their pictures up on the screen. All right, I got some couple of people waving over there. I think the next team is ready to go, so you're going to have to wait until we finish the next team. We're going to do the fan cam right after this. Ladies and gentlemen, please put your hands together for our next team, NSVIOD.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Ali Shibli. Today I'm with my colleagues Khalid Hamoud, Ahmed Al Agha, and Dr. Shakti Singh. We are representing Khalifa University of Science and Technology. Today our device is tracking the vision of UAE to make the people with disabilities involved in the community as important people in the society, and they can produce. Our project is developing a navigation system for visually impaired, which is a smart cane with a camera to detect the obstacles in front of people with visual impairment. We will explain all the stages of our project, and by the end of our presentation, we'll show a small demo.
So, visual impairment. Coming from a family that has this issue genetically, I have seen what the visually impaired face while they're practicing their daily lives. Actually, I have a grandfather and an uncle. Both started losing their sight by the age of 45, and by the age of 60, they completely lost their sight. Similar thing is happening to my father. He's losing sight day by day. And if there's one thing that I've noticed while interacting with these relatives of mine is that the visually impaired tend to try their best to prove that they're not dependent, that they can lead their own life, they can lead their own activities independently. And that actually happened to me through experience where in many cases where I offer help to my relatives, to my uncle and my grandfather, I get yelled at, I get humiliated for actually looking at them with sympathy, which is wrong. These people, they can manage to live their own life. They just need something to support them, something to help them. And this is the base of our project. This is the motivation behind the idea of our project. The objectives or the goals that we're trying to solve or trying to achieve, we want to give them dependence. We want them to be able to navigate in any unknown, unfamiliar indoor environment safely and with confidence. So now, if I was amongst the audience, I'd be like, what are these people introducing? We've seen many researchers, many projects that deal with this issue, and what are they introducing to this field? I would answer with 3 words: simplicity, mobility, and classification. In terms of simplicity, Steve Jobs once said, "Simpler can be harder than complex," and that's the obstacle we faced. We could have a big cup and super camera for image analyzing, etc. But that will not be applicable to the visually impaired. So what we try to do is we try to achieve all the goals we needed or we wanted to achieve by using simple algorithms that we can run on just a small compute stick. This helped us to have a mobile system. The user does not have to carry anything. The user does not have to put a camera on a helmet, wear a vest full of sensors, carry a laptop with him. That's not the case with us. We have a fully mobile system, which the user only has to carry or push on a 4-wheeled cane, and it will give him feedback regarding the obstacles he's facing. Now, finally, classification. We're not only doing obstacle detection. These obstacles into different categories. These obstacles could be general objects like chairs, tables, could be walls, and also could be stairs. And that's not it. We also classify stairs into upstairs and downstairs. So this is our system. It's basically a 4-wheeled cane. We have our capturing device, which is an RGBD camera. It's the device that captures the images. These images are sent to our computer stick, which is our microprocessor. It analyzes these images and sends feedback to the user through Bluetooth headphones. For the purpose of this demonstration, we're going to use Bluetooth speakers just to show you what the user hears. So the user scenario is pretty simple. All the user has to do is just turn on the computer, and the system will notify the user when he can start using the system, and it will give him feedback regarding the type of obstacles he's facing. So there are three main processes in our system: obstacle and wall detection, stair detection, and feedback. So this is a sample of an image obtained by the RGBD camera. You can see the image to the right. It shows each pixel represents a value that represents the distance between the camera and that object. So red represents further objects, blue represents closer objects. So how is obstacle detection done? So we have an image, which is represented by a matrix of depth values. This image is duplicated into two images. One is used for object detection, and the other is used for wall detection. The size for object detection is on what's exactly ahead of the user. However, for wall is usually wider, so it covers a wider angle. Then we process these images through thresholding, where each pixel is compared with a threshold, usually 1.2 meters. So if this pixel is less than 1.2 meters, it's changed into 1, and the rest is changed into 0. And at the end, we add all pixels within one matrix. So we have two summations, one for object, one for wall, and we compare these summations with predefined values that we obtain through hundreds of trials, and this determines whether the thing you're facing is object or wall or just clear.
Which is the second part of our project. But before I start, why we do stairs? Why we not recognize stairs as normal objects and tell the user that the stair is just a normal obstacle? Because stairs is very different than obstacles. Actually, the user will not need to avoid the stairs. He will need to go through them. So it's very important to specify the stairs to the user and the type of the stairs. So we're not only specifying the stairs or classifying the stair to the user, we're going further to classifying the upstair and downstair for the user. Because the user will have to act differently for each one. And stairs in general can cause serious injury to the user if he's not aware of them. The method of doing stairs is very similar to the obstacle detection, but instead of taking the whole depth image, we're taking only a small depth vector, which is going from the top to the bottom of the image. And slide. Okay. So this, as we can see from this graph here, the depth value changes according to the position when we're going from the top to the bottom. And using that, we're able to distinguish between the different type of stairs. It was noticed hence that upstair, downstair, and normal obstacles, for example, like floor, have different patterns in how the depths change, as we can see from this graph. And to be able to classify them as a program, as a computer, or as a program, we need to use a machine learning toolbox, which we are using the support vector machine, a machine toolbox that allow us to predict new sets based on predefined samples. How this works? The steps are very easy. First, as any normal machine, we need to train the machine. We train it by giving positive and negative samples. The positive samples can be any stairs, ascending and descending stairs. And the negative samples can be anything but not stair. So after we train the machine, we give it a new live cases, and the machine should predict the type of the samples based on these pre-trained samples that already defined inside the machine. As I said before, we're not only specifying stair to the user, we're going further to ascending and descending stairs. That's why we're using two support vector machines. The first one classifies to the user that if there's a stair ahead of them, and the second one is classifying the type of the stair, if it's ascending or descending stair. Finally, the system and the feedback. So stair detection and obstacle detection were integrated together to successfully identify the nature of the obstacle ahead of the user. The system provides, as we said before, a voice feedback to the user through a headset or through a speaker. And the system was designed so the user will hear the voice command once unless there's a new situation. And what we mean by that, for example, if the user went to an upstairs, the system will tell him upstairs once, the user can slow down, go through the stairs, and when he finishes the stairs, the system will tell him clear, so he can speed up. The whole process with the feedback takes around 0.5 seconds. After many tests, we found that this value is very reasonable, since the visually impaired in general does not work very fast. So we have tested and demonstrated our project in many places, inside and outside, and those are the results that we have obtained of the chance of correctly identifying the obstacle and recognize it to the user. We got around 96%, which is considered very high compared to other solutions in the market. And now we're going to the demonstration part of our project.
Upstairs. Clear. Downstairs. Clear. Wall. Clear. Wall. Obstacle. Clear.
All right, so that was the demo of the project. Thank you. So to take you back, how did we come up with this project? The idea behind this project was actually born by talking to people with disabilities and the people who work with them, for example, the Zayed Humanitarian Organization. And we asked them how we as engineers can help them make their life more productive and help them be more independent. And through unanimous feedback, which we got after talking to many people, led to the development of this project. Now, I want to reiterate that this project is not just about navigating somebody from point A to point B. It actually tells the user or helps him visualize what lies in his path and actually distinguishes between the different obstacles there may be. This helps the user take control over his own movements and make his own decision, and hence gives him a sense of independence, which is what they need. And moreover, more importantly, actually, it helps the user navigate through the stairs, which is the single biggest impediment people with visual impairment face. Now, the essence behind this project, as my colleague already mentioned, we deliberately kept everything simple, right from how the project looks like and the algorithms we used in our design. And we did that because we didn't want the user to feel out of place, or we didn't want him to feel intimidated by loading him with things like a jacket or a hat or something So hence we wanted this project to be portable and so that the user can use whatever he is using. In this case, it's a walking stick, and still be able to use this project. From our research, we do not know any product which exists like this in the market, although they do exist in research domain. And with the right kind of support and help, is it finished?
I'm afraid time's up.
Okay.
The judges will score you in case we go over. So if you want to say thank you, and then we can wrap up.
Thank you very much.
All right. Thank you to our final team in the national category there. It's NSVIOD with a great demonstration. I think it's one of the first time we got a round of applause today from the national category, all right? We're playing the highlights for you in the background, and also on the way we've got the international category. Now all the winners are going to be announced tomorrow over here. Don't forget, tomorrow from 8 a.m. the doors open. Hopefully the weather's going to be better tomorrow. At 9 we start, and we have the Drones for Good Awards happening tomorrow. Again, national and international categories. That's happening tomorrow. But let's not talk about tomorrow yet, because we still have the international AI and robotics coming up very, very soon. So make sure you stay here. Don't go anywhere. And in a few moments, we're going to kick off with the international category. And again, just a reminder that the national category are competing for a chance to win the 1 million dirham prize, and the international category are in for a chance to win $1 million US in each category. So stay tuned. In a few moments, we'll be back to kick off the international AI and Robotics for Good Awards. Thank you.